Today I'm going to be making some aluminum upgrade parts for the router. They will replace the plastic parts, which are currently on the machine. But first, the part I made in the last video has an error that must be corrected. During the final pocket operation, I had to change out a broken end mill and messed up the Z-axis homing on the new bit. This caused the pocket to be shallower than it should have been. The depth of the pocket contributes directly to the alignment of the ball screw. As a result of the error, the Z-axis ball screw would bind and flex, as you can see here. I decided, rather than reassembling the Z-axis with the wooden parts, which would need lots of alignment only to be taken apart again, I would use the wasted board as a flat reference for my XY table and the part, and indicate both the part and my XY table off the Y-axis on the machine so as to make a flat parallel pocket. I used a fixture plate and a toggle clamp to mount the plunger that comes with the router to the XY table. After doing many test cuts, with my foot on a kill switch in case something in this sketchy setup went wrong, I found the setup to be rigid enough to get the job done. So once the part and XY table were aligned, it was time to begin milling. Yeah, that startled me too. Got to make sure that depth stop clamp is tight. Honestly, the part quality didn't come out as bad as I was anticipating. Not close to perfect, but functional. It's no longer flexing in one direction as before and causing loads of binding. Now for the fun part. This is the adaptive G-code path I used FreeCAD to generate. For milling metal on a router, especially if you do not have a coolant or air blast setup, I have found adaptive paths make life so much easier. Time to throw the aluminum stock on the table and get cutting. First operation, cutting the holes with an 1/8 flute end mill. I really like how the refractive sheen on the finish looks here. Anyways, the next operation was to cut the lip and outer edge on the part with an adaptive path using a 1/4 inch to flute end mill. Lastly, I leave some material and make one last profile to cut out the part with easy to remove tabs. Alas, the part is finished. I then cut out 5 more, for a total of 6 plates. The assembly of the new parts went smoothly.